flip over to the back. Look at the back side.
She didn't do all of it, Luca.
Nope. Okay, very last one. Okay, so we're on the back side of homework 8. We're just going to do the bottom 3 to kind of set up for today. Homework 8 is what you got yesterday. Okay, it says, use your calculator to sketch the graphs of the following functions. Then describe the values for x where the function is not differentiable. Okay, first one. I'm going to grab a calculator here.
Should I grab a calculator?
Nah, I'll just put it up here. Okay, 1 over x plus 1. Where is that not going to be differentiable before I even graph it? Okay, clear. 1 over x plus 1. Okay, somebody already said it. Who said it?
-1.
Okay, -1, because what's going to happen in the graph at -1? Okay, well, if it doesn't cross out, it's going to be an asymptote. Sketch the graph. Okay, you have a vertical asymptote at x equals -1. That means that the graph is not continuous or differentiable at that value. Whoop. Okay? So it is not differentiable. Okay, ready for the next graph? Okay, absolute value of x squared minus 9. You should know this graph, but if you don't, I'll show you. Okay, what does x squared minus 9 look like? Okay, just give me the shape though. Pretend the bars aren't there.
It's a parabola.
It's a U. Where does it pass through? -9. It's a parabola. Okay, now look, watch. Don't draw this. This is x squared minus 9. If I put absolute value bars, it just takes the negative parts and reflects them back up. So it's going to be like this. Doing.
Oh, for real?
Yeah, you just take the bottom little part of the parabola, you reflect it up. Absolute value turns that part of the graph back up to positives. Okay, look at your graph. Where will it be not differentiable at?
3.
3 and -3. And why is it not differentiable? What do we call those?
Cusp.
Because cusp. Good job. Okay, last one. Y equals x minus 3. This one I wouldn't expect you maybe to know. To the power of 2 over 3. Okay, here's the graph. Ready?
It's like
Whoa. Okay, look at the graph. Where is it not going to be differentiable at? 3. Because why? Cusp. Yeah? Hello? I have Angel Horrors in my room.
Angel!
Okay, I'll set it down now. Tu padre está aquí y vas a salir pronto.
That's right.
Wow.
Yeah, that was gonna pull that out.
Pretty much broken English.
That was perfect Spanish. Are you kidding me?
Are you leaving?
Okay. All right. Got it. Okay, put your homework to the side. You should be fine. Just tell me you're leaving. Ah.
Angel, I love you. Love you.
All right. Are we almost ready? You guys, come on. This paper been up here. It's been up here for a minute.
Yeah, I'm enjoying
Thinking
it.
about an English teacher.
Meaning a little longer than a minute, you know. Okay. 5, 4, 3. Yes? You can have this paper. Come here. 5, 4, 3, 2, 1. Okay, mean value theorem. Here we go.
Magic.
Okay, so there are a total of 6 theorems you have to know. You already know 2. Intermediate value theorem you already know how to do. And L'Hopital's rule, technically that's a theorem. So you got 2 under your belt. You're going to learn 2 more today. Mean value theorem says if f of x is continuous on a to b and differentiable A to B open, then, so all it has to be is continuous with the endpoints and then differentiable between the endpoints. There must exist an x equals c within the interval from A to B, that should all look familiar, such that f prime of c equals f of b minus f of a over b minus a. Okay, write it down first. We're going to talk about it. Thank you. Okay, for these guys here, do we need to write what the symbols mean? Yoshi, have y'all seen those before?
Oh, yeah.
Okay, this means there must exist,
That formula? I see that formula.
and then that's a within, and then that's a such that.
Oh.
Okay, now keep in mind, on the AP test, they don't care if you use those symbols or not. They're not going to use them, but you're allowed to use them. It kind of shortens up the theorems a little bit. Okay, and you'll see them in college if you take a college calc class.
Boy. So if we pass this, do we not have to take calculus?
It depends what your major is. So AB, which is what you guys are in, only gets you out of one semester. So if you only need one semester, then yeah, you're done. If you need two, you'd have to take one more still.
Probably gonna have to take 2 because I'm doing engineering.
You'll probably have to take 3 then.
Oh, 3!
Plus differential equations. So you'll have to take 4.
Albert!
Okay, ready?
So busy!
But if you do like business, you only have to take 2.
Do you have to write down that formula again?
This?
Yeah.
Yeah. This?
Yeah.
Up to you, it's your notes. Okay, so I want you to draw for me, please, a quadratic and a cubic. So quadratic's going to be like this. Cubic's going to be like this. Okay? Alright, so I'm going to show you what this theorem says. Okay, first my graph has to be continuous. It has to be differentiable. Remember, differentiable means no cusps, no corners, no breaks in the graph, no asymptotes, nothing like that, okay? So I picked polynomials because those are safe. X squared is never going to not be differentiable. X cubed, never not differentiable. So both of my graphs meet those criteria. Okay, then there must be an A to B such that f prime equals this guy. Let's talk about what these pieces are. So what does f prime of c stand for? Slope of the what? Okay, I'll give you 2 choices. Tangent or secant? Tangent. Here's why. How many x's are in f prime of c? Only 1. So it has to be tangent. Okay, now what about b and a? That's the slope of the what? Secant. Because it goes through how many points? 2. A and b, right? So on your quadratic graph, I want you to put a dot here and a dot here. We're going to let this guy be A, we're going to let this guy be B, and I want you to draw the secant slope between those two. Here's what this theorem says. So this is f of B minus f of A over B minus A. That's the secant slope. This theorem promises that whatever my average slope is, that there has to be a point that matches that same slope. So if I were to draw for you on my graph, okay, I'd probably put it about right here. And do you see how at this one point, we'll call that f prime of c, my slope is exactly the same as my secant slope through the 2 dots that I drew. Okay, this is always true as long as your graph is continuous and differentiable. Okay, now go to your cubic graph. Okay, we're going to put A kind of low again. We'll put B kind of high again. So here's A, here's B. Connect your secant slope. So you're connecting those 2 guys together. Okay, that represents your f of B minus f of A over B minus A. That's your secant slope. How many places will the tangent slope match on the cubic graph? 2 places. Okay, try to see. If I was tracing my graph here, I'd be going uphill, uphill, uphill. Then as I round this curve, bam, I'm going to have a tangent maybe like about right here. Okay? Then I'm going to take my pen, I'm going to continue to follow the shape of the line, so I come downhill for a while. Then as I round this curve, bam, right there. I have another place where my slope basically matches. So in that case, instead of only one C, I would have 2 potential C's. Yeah? So I'm going to put 2 C values. Now, if you had another value where it was the same, but it was outside of the window, that would not count, because it has to be within your interval. Okay, we're going to draw one more graph. Okay, our graph is going to be, okay, kind of like the graph that you just drew on your homework. That guy right there. Okay, we're going to put A kind of low. We're going to put B kind of high. We'll put it here. Connect your dots. There's my secant slope. Is there ever a slope between those 2 dots where my slope matches exactly that secant slope? No, everything over here, the slope is negative. And then everything over here, the slope is way too steep. Why does mean value theorem not get to promise us that's going to happen for that graph? It's not differentiable. Very good. What happens in the graph that tells you it's not differentiable? Cusp. Very good. So I'm going to put MVT does not guarantee F prime at C will equal the average rate of change because cusp in A to B is not differentiable. Huh?
So A and B is going to be given, right?
Yeah, you'll have an interval to be looking at, correct. Okay? So, intermediate value theorem promises that if I pick a value between the endpoints, my graph has to equal that. Mean value theorem promises that whatever your average rate of change is, your derivative has to be equal to that. So, we're going to do like 3 examples, then we'll do some off your homework. Okay? Are we ready for example number 1? 3.
Are they like long examples?
Not really.
Like, will this be enough space for example 1?
Yeah.
What is? Oh,
Good. Here it goes. Take it away. Okay. All right, example number 1. Okay, you are going to find value of C that satisfies mean value theorem. I'm going to abbreviate that MVT. That satisfies MVT for f of x equals x squared minus 3x, bless you, on 2 to 7. Okay, so there are 2 steps that you have to do to write your conclusion for a mean value theorem. The first one is to make sure that the function is the kind of function that you can use MVT on. What 2 things does it have to be? One starts with a C. Continuous. Second one is differentiable. Now, if it's an x squared minus 3x, what is that shaped like? That's a parabola. Is that going to have any corners or cusps or anything weird? No. So for step number 1, I call that I, Roman numeral. I'm going to put f is continuous and differentiable because polynomial. Okay, not a real sentence, but you get the idea. All of your polynomials are safe. They're going to have curves, but they're all going to be smooth curves. No cusps, no corners. Step number 2, you're going to have to find what the average rate of change is so that you can promise me that it's going to happen. So the average rate of change is going to be f of 7 minus f of 2 over 7 minus 2. Which we already learned how to do this the other day, right? So let's find f of 7 first, plugging in right here. Okay, what would f of 7 be? What would I have here?
49.
49 minus
21.
21, what's that?
40 or 28.
Okay, minus. Next I need to find f of 2. So that'd be 4 minus 3 times 2 is 6. So that's a negative 2.
So it'd be plus 2, correct?
It would be a plus 2, and then on the bottom 7 minus 2 is 5. So I have 30 divided by 5 is 6. That is the exact average slope for the interval. Then what my,
It would be 6x for the slope.
Just join your calculator.
Because of my head?
Yeah.
Oh. What do you mean by 6x?
For the slope, like 6x plus 0. Like mx plus b if you put it in the slope.
Oh, yeah. But we're not going to write the equation of it. So our slope, if I were to graph this, is going to be 6. Okay, here's what the theorem promises. That there is some x between 2 and 7 where the derivative equals 6. That's all that this theorem says. If the average slope is 6, then there's at least one point on that interval where the derivative equals 6. So we're going to write it out first.
So we're going to set x squared minus 3x equals
We're going to set the derivative of that equal. But we're going to do that in a second. So first thing you would put, therefore, there must exist an x equals c within the interval from 2 to 7 such that f prime of c equals 6. So there has to be an x value where the derivative is equal to exactly 6. Now, what if I wanted to find that value? Then I'm going to take the derivative, set it equal to 6, and solve. Okay? So right below that, that's your theorem. Then if they ask you to find c, you're going to set f prime of x equal to the average rate of change. Now, what was my average rate of change? I already found it. 6. So I'm going to take the derivative, set it equal to 6. So look at your equation. What's the derivative of that guy?
2x.
2x minus 3 equal to 6, and then just solve it. Add the 3 across, what do we get? 2x equals 9 divided by 2. 4.5, or if you want to leave it as 9 over 2, that's fine. Now, question, where does your c still have to be between 2 and 7? So if I got 4.5, is that a reasonable answer?
Yes.
Yes. Make sense? Okay. Alright, 2 more left. Next one. We're going to do a little square root, because why not? Okay, number 2, we're going to find the c value, same instructions. 2 root x on 4 to 9. Root x on 4 to 9. So first thing you would do is think about the shape of the graph. Square root starts here, curves off to the side. Does it have any cusps, corners, tangents?
No.
No, it's fine. Okay, so from here, I'm going to state that it's continuous and differentiable. Okay, for the interval that we're looking at. Cont and diff, check. And then step number 2, I have to find the average rate of change. Because if I don't know the average rate of change, I can't promise what my equation has to equal. So average rate of change is the special slope the derivative is going to have to be equal to. So we're plugging in 9, then we're plugging in 4, then we're dividing by 9 over 4. So f of 9 minus f of 4 over 9 minus 4. Plug in 9 first. What's 2 times the square root of 9?
6.
Okay, minus. Next we're plugging in 4. So root 4 is 2 times 2 is 4. So if it had a plus or minus here, sure. But since the square root was already given to you, you don't have to put a plus or minus on it. Okay? And then on the bottom, 9 minus 4 gives me 5. So my slope comes out to 2/5. That is the secant slope of your graph. So now that I know what the average rate of change or the secant slope is, I can write what my derivative has to be equal to. So, therefore, there must exist an x equals c within the interval from 4 to 9, excluding the endpoints. So they should be parentheses. It can't be 4 or 9. It has to be between. Such that f prime at that c gives me 2/5. If my average slope is 2/5, I must have a tangent slope also equal to 2/5. Now let's say I wanted to find it. What would I do? I would take the derivative, set it equal to 2/5, and then solve. Where should your answer be? Between 4 and 9. So let's do it. Now, if this is a square root, we're going to need a rewrite. So I'm going to put here to find c. Okay, I'm going to rewrite 2 square root x as a what? 2x to the half. Good. So let's take the derivative of that. So I take my 1/2, I times it down. What's half of 2? 1. Then I have to take away 2/2. What is 1/2 minus 2/2? Negative 1/2. Now, I don't really like the way that that looks, so how could I rewrite that if I don't want that negative exponent there? 1 over, very good. So it'll be 1 over root x. Now, what does that have to equal? What was our special slope? 2/5. Okay, you have a couple options here. You can think about it as cross-multiplying if you like that better. I'm just going to flip both sides. I don't want the x on the bottom, so I'm going to flip here, then I'm going to flip here. So 1 over root x is now root x, and 2/5 is now 5/2. And then how do you get rid of the square root? Square both sides. When you square a fraction, just square the top and the bottom. So I'm going to put my squared here, squared there. These guys cross out. I get x equals 5 squared on top is 25. 2 squared is 4. Now, quick question. 25/4 is pretty close to 24/4, right? Which is about what? 6. So it's around 6. Is that going to come out to be between 4 and 9? Yes. So you should double check that just to make sure. But if this number is not between that domain, then you know that you messed up or that you can't pick it. Okay. Good. Do you have a question? No? Okay, turn the page. Last example. The last one. Okay, number 3. Okay, your equation is going to be f of x equals 1/3 x cubed minus 2x squared. You're going to be looking on 0 to 3. First thing you're going to do is check to make sure that it's the type of function you're allowed to use this on. It has to be connected, has to be differentiable. So if it's x cubed, that's a polynomial. So I'm going to put cont and diff because polynomial. Okay, you're just thinking about the shape. We know what a cubic looks like, so we're not worried about it having a cusp or corner or any of those weird things. Okay, item 2, you have to find the average rate of change so you can promise to me what the slope has to equal. So average rate of change on 0 to 3 is f of 3 minus f of 0 over 3 minus 0. There shouldn't be an equals there, really. Okay, do 3 first. 3 cubed. 27. Now divide it into a third. 9. Okay, so I have 9 minus. Then I'm plugging in my 3 here. 3 squared is 9 again. times 2 is 18. What's 9 minus 18? Negative 9 minus. Now I'm plugging in 0. 0 is going to be easy. 0 cubed is 0 times by a third, still 0. Minus 2 times 0, still 0. So my y value is 0 for the second one. Divided by 3 minus 0 is 3. Negative 9 over that is negative 3. That's the average rate of change. My slope has to hit that number for that to be the average. So there must exist x equals c within 0 to 3 such that f prime of c equals negative 3. There has to be a value where my derivative comes out to be negative 3. If that's the average, there has to be a point where that's the tangent slope. Okay, from there, if I asked you to find c, what would you do? Take the derivative and set it equal to negative 3. So what's the derivative of this guy? Just normal power rule there. Okay, so 3 times a third is just a 1, x squared. Then 2 times minus 2 is 4x. X is now to the 1. And then what are we setting the equal to? So this side is f prime. This side is the average rate of change that I already found. Now, how are we going to solve that if it's quadratic?
Move it over, right?
Yep, we need to factor it. So my minus 3 is going to have to come over as a plus 3, and then we're going to factor how many solutions are we going to find?
2.
2. Could they both be on the interval? Sure. Do they both have to be on the interval? No. So, factor, what will multiply to 3, subtract to negative 4? Negative 3 and negative 1. Which means what are my two x's?
Positive 3, positive 3.
Positive 1, positive 3. Now, can both of those be c?
Yes.
Which one can't? 3. Because where does c have to be?
0 and 3.
And this is an open interval.
Oh.
Gotcha. Okay, so you can't pick 3 because it's the endpoint. If these are open, 0 to 3 between them, not including those 0 or 3. So 1 would be my only c. Because they're open in the theorem.
They're not brackets.
So yeah, if they were, that's a good point. If they, so yeah, so this is the interval we're doing it for, but your conclusion, they're open. For all the time, for mean value theorem. Okay, so get out your homework. Get it out, get it out. Okay, I want you to do, sure, 2 and 6. 2 and 6.
Which one? Which one?
Just off the top section. The homework you picked up today.
Today. What?
Yeah, you can grab it.
Yeah. There's 3 homeworks, guys.
No, she said homework you wouldn't turn in.
The new one you have to.
Hey, everything, did you want one?
Do you need one, Yoshi?
Number 7 for you guys. She's the one I turned in.
Look, there's 2 number 7s. That's the one you turned in.
Please join her.
Okay, so you're looking at your homework, you're doing number 2 and number 6.
We're fine with that.
3. Do you want it? 2, 6. Thanks, Yosh.
Definitely better than the
What? She'd be crying to hear it.
Definitely better than Coach Erickson. Ooh!
Gotta get the rest of it.
Well, yeah. What is this, a group potty break? Go ahead.
I've been trying to do this.
Just go, bro.
I don't want to do it.
You gonna let him
I'm gonna run into
first?
Kane. I'm gonna run into Kane.
I just said you. Just hurry up. It's not gonna. What are we doing?
Can I just wait till they go back?
Yeah.
Okay, number 2. Is mean value theorem gonna apply or not?
Or no.
Number 2. No, why?
Because 2's in the interval.
Okay, very good. Look at your function. If there's an x minus 2 on the bottom, where does that have an asymptote? 2. Because if I put a 2 in there, I get 2 minus 2. That gives me divide by 0, and that means there's an asymptote. So I would put MVT does not apply because f of x has a vertical asymptote at x equals 2. Now, quick question. What if my interval was like 5 to 10? Then would you care if there's an asymptote at 2?
No.
No, because it's not on the interval. But 2 is directly between 1 and 4. That's why it's a problem. The section of the graph I'm looking at from 1 to 4 includes that asymptote. And that is what gives you the whole problem. Okay? All the other ones it should work for. So let's do number 4, and then we'll do 6. Okay, number 4, take a look at it. Sine x. Okay, think about the graph of sine x. Does it have anything weird? It goes like this. Ooh, 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 ooh. It's good to go. So, continuous and differentiable, check. Okay, we know what the graph looks like. You just think about it. No cusps, no corners, then it's good to go. Okay, step number 2. I need to find the average rate of change. So that'd be f of pi minus f of 0 over pi minus 0. And whatever that average rate of change is, I can promise you that my derivative is going to equal that. So plug in pi first. What is the sine of pi? It is 0. Yeah, because look, here's 0, here's pi. So both of them are on the axis. So if you're doing your hand trick, here's pi, fold the finger down, no fingers on bottom, then it's 0. What about the sine of 0? 0 again. 0 minus 0 is 0. Now, question, am I allowed to divide 0 by pi? Sure. 0 can be where? On the bottom, but it's allowed to be on the top. Okay, so from there, my average rate of change is 0. Then I'm going to say there must exist an x equals c on the interval from 0 to pi such that f prime of my c equals 0, because that was the average rate of change or the average slope on that interval. Okay, then to find it, what do? Take the derivative, set it equal to 0, and solve. So to find our c, what is the derivative of sine x? Cosine x, good. And then set that equal to 0. So this says y prime is cosine. I set it equal to the average rate of change, which I already got to be 0. When is cosine 0? What was it? Pi over 2. Here's how you do it on your hand. I want no fingers on top. Then I have to pick this guy. Now, I could also pick 3 pi halves, right? But where do I have to stay between? 0 and pi. So can I pick 3 pi halves as my c? No, because it's not between those endpoints. So your c there would be pi halves. You what? Yeah. Oh yeah, we did it. Oh, but he just came in from BC. So. Yeah. A loner in the bathroom. I hate when people try to talk to me in the bathroom, you know?
I know, it's
Like teachers always do that. Like I'll go in and be, how's it going? How's your day? And I'm like,
Shut up, Karen. I'm trying to
yes, thank you. Karen, we'll talk during lunch.
Your name's Karen?
You still dating that cute boy? Okay, I'm goofy right now. Okay. Huh? No, there's not like a real lady here named Karen. It's just like, ambiguous, the name of a lady you would talk to in the bathroom,
The name of the lady who'd also ask for the manager, and the name of the lady.
Oh yeah, Karen's asking for the manager, for sure.
Changes the title of Joe. Right there.
45. Okay, let's finish 6, and then you have to stop on your homework here. We're going to do Rolle's theorem tomorrow. So, look at number 6. First question, do you know what that looks like? Maybe, maybe not. Let's see what it looks like. So, y equals x to the power of, what would my fraction be? 2/3. Okay, look at your graph. There it goes.
It doesn't work because there's a cusp.
Okay, now, careful. Where is the cusp?
1 and 8.
At 0. Where am I looking at the graph from? 1 to 8. So is my graph good to go?
Yes.
Technically, yes. Even though there's a cusp, it's not between these numbers, so we don't care. Okay? So, from there, I'm going to put it's continuous and differentiable on 1 to 8. Check. Because this one's not continuous everywhere, or it is continuous everywhere. It's not differentiable everywhere. So I'm going to be specific. It's not differentiable everywhere, but it is on my interval. Okay, step 2, I find the average rate of change. A rock, 1 to 8. So that's f of 8 minus f of 1 over 8 minus 1. Now, when you're plugging into roots and powers, what I would do, here, let me write it. It'd be the cubic root of 8 squared minus the cubic root of 1 squared. I would do the root first and the power second. That's you. So this is what I mean by that. What's the cubic root of 8? It'd be 2, and then what's 2 squared? 4. So go smaller first, then go bigger second. So cubic root of 8 is 2, 2 squared is 4 minus, and then 1 to any power is just still 1. No?
3/7.
Are you talking about this part right here, Ebenezer? So you do the cubic root of 8, so you get 2, and then you square it second. So do the root first, power second. So then what's my average rate of change? 3/7. What that means is there has to be a point where the slope is 3/7. So there must exist an x equals c within 1 to 8 so that f prime of c is 3/7. There has to be a spot where that's my exact slope. Then how do I find it? I take the derivative, set it equal to 3/7, and then solve. Where should my answer be between 1 and 8? Now, huh? Okay, good question. We're going to have to do a rewrite. How do you rewrite this guy? X to the 2/3, yeah. So you'd make it the power on top and then the root on bottom. So let's take the derivative. My 2/3 moves down to the front. And then when I take away 3/3, that's the same as 1. What's 2/3 minus 3/3? Negative 1/3. Now, I don't want to set it equal looking like that, so I'm going to fix it. Okay, I'm going to take my negative 1/3 power and put it on the bottom. So it would be 2 over 3 cubic root x equal to 3 over 7. Everybody good on that? Okay, then I don't want my x on the bottom, so I'm going to flip both sides. So this is now a 3, I'm going to have to write over here, sorry. 3 cubic root x over 2 equals 7 over 3. So I flip and I flip. Then from there, how do I get rid of a 3/2 in the front? Multiply by what? 2/3 and 2/3. What does this come out to be then? 14 over 9. And then how do you get rid of the cubic on the x? cube, and cube. So your answer would be 14 over 9 cubed. Now, little bit of reasoning here with our numbers. Okay, 14 over 9, what whole number is that a little bit less than?
1, 2.
Bigger than 1, a little less than 2, right? Because 18 over 9 is 2. So if it's a little bit less than 2, and I cube it, is that going to come out less than 8?
No.
Yeah.
Yeah.
Because 2 cubed is 8, so a little bit less than 2 cubed is a little bit less than 8. Make sense? Okay. Alright, don't forget y'all have early release tomorrow, and then open houses tonight.
What's the schedule for early release?
3 over 7 was equals less than 1 at 2 over 6.
No, not at all.
Because 3 over 7 is less than 1. What do you mean by that?
It's tonight. The house is tonight.
Uh-huh. From 6:30 to 8. No, that doesn't matter. It doesn't matter that the average rate of change is on the article. It matters that your C. Does that make sense? So your average rate of change, the F of B minus F of A, that graph can be 106,000. But your C value. Have the best day.
I can't.
Huh?
You didn't call me.
The same
Let's go right now.
last year, yeah. Thank you for remembering. I think though that remember last year I didn't feel it right because I went on that cruise, and so for my sister's bachelor party, and so I think that's why I didn't feel right. And it got me.
Jordan, can I ask?
You're coming back to me 8 or 6?
I'm coming today.
Oh, okay.
In the morning, we can.
After school today? Okay.
In the morning.
Okay.
No, I'm not coming today. I got
For tutoring.
I'm out, but I asked for more. If you come tomorrow, I'll have them. Sorry. Gotcha. Okay, cool. I will be here on Friday. Yes. Bye, Sue. Oh, I have Rams University. Worst class ever.
Is that on ramps?
No, it's like the freshman